Okay, looking at number 10 on the exercises here. Seems like a pretty standard setup, but there's a little bit of a twist on this one because we're going to be doing this. This question is going to deal with the second derivative test, so we're going to need to find the second derivative. Can we find actual values of the second derivative of g prime? No. Right, because the g double prime would be the slope of this line, and although I could draw that in, I can't find those exactly without the actual function. But the second derivative test is all about the sign of the second derivative. So all of the problems at the bottom can be solved, even though you don't actually get the second derivative's value, but you can tell its sign in each case. So let's look at one or two of these just to kind of get a feel for what I'm talking about. So we have a function. F is a function that's twice differentiable, so we can take the second derivative. And f prime equals g prime of x times h of x. So f is some sort of unknown function that we have, and its derivative is made up of g prime, so these values, times h, which are these values. So if you need to find the derivative of f, look to this table and look to this curve, right? Okay, weird setup, but that's how it's set up. We want to know if there's a local minimum, local maximum, neither, or cannot be determined. And I believe these 4 questions hit all 4 of those things. So first, to decide whether we have a local minimum or a local maximum, we have to check to see if we have a critical value. Since our function is twice differentiable, that means our critical values will be 0. We won't get an undefined. Otherwise, we wouldn't be twice differentiable. So start there. We'll start there with A and B because those are the ones that I want to take a look at. Let's find f prime of those values. F prime of -1 is g prime of 1, read from the graph, times h of 1. Let me I have it right here instead of flipping up. So you guys have this paper in front of you too. Okay. So using the definition of f prime, there it is. We've got the g prime of -1, and then that's going to be times the h of -1, which are either of those 0? Is basically the question. Yes. So that's going to be 0 times something else, which looks like -4, equals 0. So is it possible that x is a candidate for a local minimum or local maximum?
Yes.
Yes. Yeah. Yes. F prime of -1 is 0. So f prime may have a local minimum or a local maximum at that value. Let's do the same thing with 0. Just kind of do the steps one at a time here. F prime of 0. Sure. Yeah. I'll come over. Sure.
Thank you.
So f prime of 0, I'm going to recycle my thought process and write the same thing. G prime of 0 times h of 0. Are either of those things 0? No, right? That's what I thought was going to happen when I looked this the other day. So it looks like it's about 1.5. So I'm going to use a squiggly equal. So we've got about 1.5 for g prime of 0, and then h of 0 is exactly 3. And then I'm just going to say that this thing does not equal 0. So f prime does not equal 0. And we're good there. So here I've already got my answer. This is no local minimum or maximum, no relative extrema, which is different than cannot be determined. We just determined it, right? Keep that in mind as you're doing things like this. All right. So now our only option for local mins and local maxes is the second derivative test because h is given as a table, so a sign chart is not a thing. So we have to do the second derivative test. So we will find the second derivative of f double prime of x, which is the product rule. So it's going to be derivative of the first, so it's going to be g double prime of x times h of x plus g single prime of x, h single prime of x, right? Okay. And now here's where looking at the graph and just determining if it's positive or negative comes into play. F double prime of -1, recycle any values from the top. I know